This tutorial is going to cover basics of graphing sine and for cosine. So to start with, we're just going to talk about how to graph the parent functions for sine of x and for cosine of x. Just like in class today, we talked about taking your x-axis and breaking that down into equal portions. And so we're going to go ahead and mark off a portion at the origin. And this is more how we're going to do it even when it gets more difficult. We'll go ahead, we'll mark where the period ends. And for sine and for cosine, we know the period is always equal to 2 pi over b. So it would look something like this. So period is equal to 2 pi divided by b. And b is always the coefficient for x. In this case, period is just 2 pi, because in our example here, a is 1 and b is also 1. So a equals 1 and b equals 1 as well. So we're going to come down here and we're going to go ahead and we'll put those values in. So about halfway, and then we'll go ahead and make again halfway here. And so I've given these are my quartiles. These are dividing up my interval into 4 parts. And so we can come down, and this is going to be, I'm trying to draw this with a mouse, which is no good. So 2 pi here, and if we come halfway, and this is going to be pi, and of course this is pi over 2, and this one's going to be 3 pi over 2 as well, or this will be halves as well. And this point, this is really automated, and we understand that this one back here, this is also 0. I'm going to go ahead and I'm going to always approach graphing sine and cosine in this way. I'm going to go ahead and put the ending of my period as well as the beginning of my period. We're going to go ahead and put halfway between those values, and then we'll put the halfway marks here and here. So the quarter mark and then the 3/4. We're going to give ourselves the amplitude, so our A is 1, so that means our amplitude is equal to 1. If we remember from class, amplitude is, over here, all right, amplitude is equal to the absolute value of A. And so we'll go ahead and mark that off. We know that for sine and for cosine, the maximum and minimum values for that is just 1 and -1. You can look at the unit circle, and you can go all the way around, and you can look at all the x and the y values and look at what's the largest y value, what's the largest x value in terms of just sheer absolute value. You'll find it goes from -1 all the way to +1, but it never goes outside those ranges, and that's exactly the amplitude, and that's the minimum and maximum for sine and for cosine. And so if I come in here and we go ahead and we mark out those critical values, we know that sine starts at its origin, or starts at the midline. It's going to hit its midline back again at the center or the middle, and again at the end. We know that sine hits its peak first, right? We know this because we've looked and we've learned what the parent function is supposed to look like. If I didn't know that, I could type these things into my calculator and see what it gets. These are all whole values, so if I type in sine of any one of these values that we have down on the x-axis, it's going to give me either 1, 0, or -1. So if you forget, it's not a big deal to simply type it in and go from there. I'm going to try and draw a smooth curve, which is probably not going to happen. So we have sine, it goes down through the center point, it hits its minimum, and returns. That was almost nice. Yeah. So you get a good idea of how to draw the sine function. I don't know if you're going to memorize this or if you just kind of learn a way that you can always remember how to draw it. It's not a bad idea to memorize this graph. Memorizing sine, cosine, and tangent as a parent function is probably a good idea. Let me just summarize one more time. Right, we started at the minimum. We started at its midline. The midline here is the x-axis, which is y equals 0. We went up to the maximum. That's at pi over 2, and the y coordinate is +1. We went back down through the minimum, or the midpoint, which is halfway through its period, which it hits 0 again. drops all the way down to its minimum value at -1 at 3 pi over 2, and goes back up to positive, or it goes back up to 0 at pi over 2. And this is one complete period of sine. If we come back up here, we can fill in these values, which we talked about earlier. It's 2 pi divided by 1, and the amplitude would be easy. It's just exactly 1. So here we have 2 pi is my period and 1 is my amplitude. You can see that from the midline all the way up to the top is 1. From the beginning 0 all the way to the end, or before it starts to repeat itself, is 2 pi. Let's look at cosine. So we have the similar values. I'm not going to repeat the formulas we wrote up top, but we know that just because a and b are both 1 here, that if a is equal to 1 and b is equal to 1, then our amplitude is equal to 1 and the period is equal to 2 pi, if I can type today. So we always want to identify all these different values. What's A, what's B, and eventually what's C and D, and then what's amplitude, period, phase shift, and vertical shift. That's kind of how we're headed. But let's go ahead and draw this one, just so you can have a frame of reference. So we're going to go ahead, just like before, we're going to mark out that's 0. I'm going to go ahead and mark out the end of my period. Let me get the right color. Use blue. So we're going to mark 0 as the beginning point. 2 pi is the end point. So 2 pi. I don't ever recommend trying to draw with the mouse pad. So here's pi. And here is, well, it's half of where we were before. So if we are at pi and we divide by 2, then you're clearly at pi over 2. And I hope you're going to get this idea that I halved. So if we go back up, I put the end down, right? So the whole period is 2 pi. Well, half of that value, that distance, is pi. And then half of that distance is half pi. But we want to go from here. And at this point, it's not difficult. You can think about this as, 50 cents each time. So this is 50 cents, $1, $1.50, and then $2, something like that. Something to break up something that's common. So we're going to go ahead and we'll draw in 3 pi over 2. And we'll have to remember that's nice. Our amplitude comes up next, or you can do this first. That's usually one of the easiest things to identify, amplitude and vertical shift once we get to that. So this is -1 here. Yeah, that's not a 1. Seriously, come on. There we go. Now we're going to go ahead and put in the critical values. We've got cosine. If you can't remember, we can go ahead and add in and find out what is the cosine of 0, or what is the x-coordinate of 0. And we find out that that gets us a positive 1. If we take the cosine of 90, you can look at the x-coordinate of 90, that's actually 0. So that puts us right back on the midline, or the x-axis. If you go to pi, you know that x-coordinate is -1. And then here again, we're back at 0 and back up at our maximum value of 1. So if we draw the cosine, notice the cosine and the sine are smooth curves. They're not, let me make my point here, they're not this. I will most definitely mark off for that. That's an absolute value function. That's not the sine of, or the cosine of anything. So make sure that you are having your curves be smooth as they come down, something like this. Okay, those keep on going. I'm only going to draw one period, and that is the most horrific cosine I've ever drawn. So go with me. They're curved. Make them curve in your drawing, so do your best you can. The more you do it, the easier it'll get. Here we got cosine. This is a full period of cosine. It starts at its max. It ends at its max. We notice that cosine on the half pi's goes through the x-axis. And if you continue this process on, if we're at 1/2 here and 3/2, then the next one's going to be 5/2. Notice it skips every other one. This is actually 2/2 and 4/2. So at 5/2, it's going to go through the x-axis again. Then it's 7/2 and 9 and then 11, and it keeps on going. At the whole pi's, Cosine is at its minimum or its maximum. If it's an odd pi, it's going to be at the minimum. If it's an even pi, it'll be at its maximum. And you can keep this process going on. And eventually we'll get to drawing two periods of these functions, and you'll see very clearly all the patterns that lay out. So the more you recognize, the more patterns you're aware of, then the easier these graphs become to draw. And that's it. At this point, I just want you to be aware of the cosine and the sine in their parent graphs. Any questions, bring them with you tomorrow to class.